Okay, you know from your daily experience is that there are different seasons in a earth during an year. That means sometimes you feel very hot and sometimes you will feel very cold, and these variations of seasons on earth as a periodic nature. So these variations in seasons or seasonal variations as a periodic nature because it is having some relationship with the rotation and revolution of earth. Or we can say that the seasonal variations are completely relied on the revolution and rotation of earth around the sun. During summer you can feel very hot. It is because more energy is reaching on earth from the sun during the summer season. More energy means more light is reaching on earth during summer, or we can say that the quantity or the amount of sunlight reaching on earth will be greatest during the summer, and the quantity of sunlight reaching on earth will be least during the winter. The quantity of the amount of sunlight produced by the sun will be same throughout a year. There is no variations in the quantity of sunlight produced by the sun, or the energy produced by sun in a year is not possible. The reason is that the sun's path across the sky is varying in an year. Or if you consider the summer season, the path of sun across the sky is highest, and during the winter the sun's path across the sky is lowest. So sun will take a large time over the visibility or over the head of earth during the summer seasons, and winter season this path of sun across the sky is lowest. So this makes the seasonal variation. This also you can, from the daily experience you can feel that the altitude of the sun above the horizon at noon varies during the year because the earth's axis is tilted to the plane of its orbit around the sun. That you can see from here. Here you can see this is earth and this is the sun. This one actually represents the axis of earth. This axis of earth is actually having a slanting with respect to the orbital plane of earth around the sun. So this is the orbital plane. If the axis is not tilted with respect to the orbital plane, the axis would have been like this. But you know that the earth's axis is tilted with respect to the orbital plane, so that earth line axis will have a slanting or a change during in a year. So since the earth's axis is tilted, each hemisphere gets varying amount of sunlight during the year as our planet orbits around the sun. If it were not tilted, then each hemisphere will get the same quantity of light from the sun during an year. If you consider these two positions, that is position at June 20 or 21st, and during December 21st or 22nd, they are exactly 6 month difference. Here during June, you can see the North Pole and the nearby points will get a sunlight during the June. After 6 months, when it reaches the other diametrically other end of this orbital plane, exactly diametrically opposite end, then you can see that the North Pole is and its neighboring point is not getting any sunlight. If you consider the South Pole during the June, it actually does not get any sunlight during this June, but during the December, after 6 months, the South Pole is getting sunlight. So you can see that during June, the northern hemisphere of Earth is getting more quantity of sunlight, and during December, the northern hemisphere of the Earth is getting least quantity of sunlight, while the southern hemisphere gets greatest quantity of sunlight during the December, and southern hemisphere gets less quantity of sunlight during the June. That means you can see that from this one you can say that since this North Pole or northern hemisphere is getting more quantity of sunlight, then the energy reaching on the northern hemisphere during June will be greatest. So the temperature of on the points of Earth at these positions will be more when compared to the other seasons. So we can say that the northern hemisphere of the Earth will feel summer seasons during June 20 or 21st. But during December, the northern hemisphere of Earth is getting least quantity of sunlight. That means the energy reaching from the sun to the Earth is least during December on the northern hemisphere. So northern hemisphere will have a winter season, but at the same time the southern hemisphere is getting more sunlight during this December, and this southern hemisphere will have summers during the December. So we can say that this slanting or the tilting of Earth's axis of rotation with respect to the orbital plane of Earth around the Sun is the reason for appearance of seasons and seasonal variations on the surface of Earth. Now if you consider this diagram, here you can see the Earth is at the center. Definitely the sphere around the around the Earth will be the celestial sphere, and this point represents the celestial North Pole and this point represents the celestial South Pole. Since Earth is revolving around the Sun, what we will feel is that Sun is revolving around the Earth through the celestial sphere. The trajectory or path of the Sun round the Earth through the celestial sphere is called ecliptic, and you can see an equator of this celestial sphere which is called the celestial equator, which is actually the extension of the Earth's equator to the celestial sphere. So when you consider the Earth's equator which is extended to the celestial sphere, you can have a celestial equator, and this celestial equator and the ecliptic is having angle of 23.5 degrees or 23 degree 30 minutes. So from here we can say that Earth's equator remains tilted at about 23.5 degree to its orbital plane all year long. So as Earth travels around the Sun, the slant of the Earth-Sun line changes. That means the sunlight pours down to Earth from different angles during the year, causing the changes of seasons as well as seasonal variations, and it will cause the change in the length of days and nights. So that is very clear from this diagram that the Earth's equator will have an angle with the orbital plane, and this angle is 23.5 degree. Due to this tilting of Earth's axis, the different hemisphere of Earth will get different quantity of sunlight during an year, which causes the different season to experience on Earth's surface. The day for seasons on Earth we can classify into four. That is, they are called the vernal equinox, the autumnal equinox, the summer solstice, and the winter solstice. That we can discuss from this diagram. Here you can see the Earth is at the center, and here the celestial equator is shown here, and the ecliptic is also shown here. Now if you consider this point, the importance of this point is that it is the sun's position as it crosses the celestial equator going north. So this is the celestial equator, the sun's position which crosses the celestial equator when it is going north, which is called vernal equinox. So vernal equinox is the sun's position as it crosses the celestial equator going north, which actually occurs around March 21st. Usually it is 20 or 21st. Usually occurs in March 21. In more general, you can say that it occurs either during March 20 or 21, depending upon the points on Earth. So now, this point, vernal equinox, is considered to be the 0 hour of right ascension. Right ascension means, you may remember about the latitude and longitude, which are the two coordinates used to locate the positions on the surface of Earth, or it is the coordinate used to locate the points on the terrestrial, used to locate the terrestrial points. This right ascension and declination are the two coordinates used to locate a point on the celestial sphere. So the celestial points are represented by the two coordinates, namely right ascension and declination. You may be heard about the, or remember the latitude. Latitude means it is the angular distance of the point towards north or south from the terrestrial equator. So the declination will have almost the same meaning. Here declination is the angular distance of a point towards north or south from the celestial equator. So it is declination is actually used to represent points on the celestial sphere. So it actually a distance of the point from the celestial equator towards north or south. Similarly, you know, remember the longitude. Longitude is the distance of the meridian passing through that point from the prime meridian, and it is having the same meaning as that of right ascension. The right ascension is the distance of a point from the vernal equinox to the meridian of that point. So vernal equinox is taken to be the 0 hour of right ascension. That means if you consider the meridians on the celestial sphere, one of the meridian will pass through the vernal equinox, and this meridian, this is taken to be the 0 hour. Now to locate this point on this celestial sphere, we have to specify the right ascension and the declination, which is the coordinate used to represent all the celestial objects. That means in order to specify the position of a particular star in the celestial sphere, we will use this right ascension represented by Ra and the declination represented by DEC. So to locate this point, we have to specify the right ascension and declination. Right ascension means there is the angular distance of this point from the celestial equator to this point. So this is the declination. Right ascension is the distance of this point from the vernal equinox. So this right declination will have the unit of degrees, minutes and seconds. Right ascension will have the units of hours, minutes and seconds. So anyway, the vernal equinox is taken to be the 0 hour of right ascension. That means vernal equinox will have the same meaning as that of prime meridian, which is passing through the airy transit instrument in the Greenwich. Now if you consider this point, which is exactly diametrically opposite end of the vernal equinox, here it is the position of the sun as it crosses the celestial equator going south, which is called autumnal equinox, which occurs during September 23. So autumnal equinox is the sun's position as it crosses the celestial equator going south, which occurs during September 23rd. And the interesting thing regarding the autumnal equinox and vernal equinox is that the duration of day and night are same. Or we can say that at equinoxes the day and night are equal in length. That means if you are having 12 hours of day, then we will have 12 hours of night during the both vernal equinox and autumnal equinox. That is one of the interesting thing regarding the equinoxes. Now you can see two more positions. One is the sun is at the most northern position, which is called summer solstice, because on the northern hemisphere we will feel or we will the people on the northern hemisphere of earth will experience summer during this point, which occurs during June 21, which is exactly 3 months after the vernal equinox. So summer solstice is the position of the sun at the most northern point, or at the most northern position from the earth, which occurs during June 21, and during that time the northern hemisphere of earth will experience the summer season. That means the northern hemisphere gets more sunlight during this summer solstice. Now if you consider this point, this is the point in which sun is at its most southern position from the earth, and which is called winter solstice, which occurs exactly 6 months after the summer solstice, or 3 months after the autumnal equinox. That is, winter solstice occurs during December 22. So during December 22nd we will have the winter solstice. Winter solstice is the point in which the sun is at the most southern position from the earth. At that point the southern hemisphere of the earth will get more sunlight, and we will have summer during this winter solstice in the southern hemisphere of earth. We are all in the northern hemisphere of earth, so we will experience winter during the winter solstice. That is, the northern hemisphere of the earth gets least amount of sunlight during the winter solstice. So we will feel winter seasons, or we will experience winter seasons during winter solstice. So that is the different seasons on earth depending upon the quantity of sunlight reaching on the earth. The reason for experiencing different season on earth is due to the fact that earth's axis is remain tilted with respect to the orbital plane of the earth around the sun. So that's all about this chapter, the earth. So we have discussed almost all thing about the earth. Now we have to discuss about the sun, that we will discuss in the next lecture. Thank you.